Hello everyone, I am Bhavani, Assistant Professor in the Department of IT at SMIT. In this lecture, we are going to discuss about the DBMS, Database Management System. Now we are going to see course outcome. Course outcome 1, we are going to look into construct SQL queries using relational algebra. In this, we are going to use the algebra operator symbols like sigma, pi, union, etc. to construct SQL queries. Course outcome 2, design database using ER model and normalize the data. We are using queries and then entity relational model followed by refining its logical structure through normalization to reduce the redundancy and improve data integrity. And then moving on to course outcome 3, construct queries to handle transaction processing and maintain consistency of the database. It explains about the construction of SQL queries to handle the data transaction process from one system to another and maintaining the consistency in between them. And then course outcome 4, compare and contrast various indexing strategies and apply the knowledge to tune the performance of the database. In this unit, we are going to implement the SQL techniques and various indexing strategies and then apply our knowledge to tune the performance of database. Course outcome 5, appraise how advanced database differ from relational database and find a suitable database for the given requirement. Here we are going to learn about the advanced topic of DBMS differ from relational database. Then syllabus, first unit relational databases. In this we are going to cover about purpose of database system, views of data, data models, database system architecture, introduction to relational database, relational model, keys and algebra, fundamentals, and then advanced SQL features, embedded SQL and then dynamic SQL. Unit 2 will be database design, 3 transaction, 4 implementation techniques, 5 advanced topics. Now moving on to session, database system. First we need to know what is database management system. It is a software that helps us to store, manage and retrieve data easily and safely in an organized manner. See, let me give you some example of DBMS. It will be MySQL, Oracle, MongoDB. Then actually see what is database. Database is a structured, organized collection of data stored electronically like a digital filing cabinet. See, data refer to raw unorganized fact and figures such as number, text, images or symbols that can be processed and analyzed to extract meaningful information. Data can in the form of raw forms like unorganized, like it won't be in a structured form, it will be in the form of videos, photos like that. Structured form means it will be in the form of rows and columns. See, database is a structured collection of data. Structured means same rows and columns. Data will be in an organized way. Designed for efficient storage, retrieval and manipulation. It serves as a centralized repository allowing data to be accessed, managed and updated by the multiple users. And then purpose of database management system. See, the purpose will be for efficient data storage, data retrieval, avoid data redundancy and then maintain data consistency. First, efficient data storage. Huge data are stored in an organized way so it is easy to access. Okay. Then data retrieval. We can fetch data using SQL queries. We will be using SQL queries to fetch the data. Okay. And then avoid data redundancy. There should not be any duplicate data in the formation of data. Avoid duplicate data to save space and improving consistency. Maintain data consistency. Does not connect direct or indirect contradiction. Okay, like when one copy of data is updated, changes reflect everywhere, ensuring accurate and synchronized data. Moving on to views of data. There will be 3 views. First view will be physical level, logical level, view level. Physical level known as internal level. This will be otherwise called as lowest level of abstraction. And then second, moving on to logical level, otherwise known as conceptual level. It seems to be middle level of abstraction. Moving on to third level, view level. This is called external level also. This is the highest level of abstraction. Okay. And then tell me, what is abstraction? Removing of impurities or unwanted data and giving the precise data correctly what is needed is called abstraction. Okay. Then physical view shows how data is actually stored in the database. Example, data stored on disk using B trees or hash files. Okay. This is deals with files, index, storage structures. Moving on to logical view, show what data is stored and relationship between data. Does not show storage details and all. Example, tables like student, course, marks and all can be only viewed. Other than that, nothing can be viewed. Okay. And then view level shows only required data to a specific user. Different user can have different views. Okay. Like example, I can tell you, student sees only the marks. Admin can sees only the full student's detail. Now moving on to data model. Data model is a way of organizing, describing and relating data in a database. It provides a frameworks for how data is stored, connected and accessed. In this data model, there are 4 divisions: relational data model, entity relational data model, object-based data model, and then semi-structured data model. And then moving on to database system architecture. This diagram represents the DBMS architecture. It is known as data pre-processing. Raw data may or may not contain errors and inconsistencies. This is the process of cleaning and transforming raw data before analyzing model. C. External level, conceptual level, internal level. This is the architecture diagram. Then 3 levels of architecture. External level, this is the view level. At last to first we are going highest level of abstraction. Like what I told, shows only the part of database that particular user needs, and then ensures security by hiding sensitive data. Different users get different customized view. See, example, student sees only the mark, not the student's record. Conceptual level, otherwise known as logical level. See, this is the middle level, describes the entire database structures. Focus on what data is stored in relationship. Contains table, attributes and constants. Example, ER model, entity relationship, relational schemas. And then moving on to internal level, physical level. This is the lowest level of abstraction. Okay. Defines how data is actually stored in memory. Deals with physical storage, indexing, file organization and data blocks. Example, storing a student record in a block like B-tree indexing or in a hashing method. Now moving on to introduction to relational database. Relational database is a type of database that stores data in the form of tables, or also called relations. Each table consists of rows and columns, making data easy to understand, manage and query. Relational database were introduced by E.F. Codd in 1970 based on relational algebra and set theory. First we can define what is relational database. Okay, like a relational model. Let me tell you, relational model or relational database is nothing but database where to store the data. Relational model, same proposed by E.F. Codd in 1970, most widely used data model in modern database. It represents data in the form of table, relations, rows considered as tuple and column as attributes. It is the foundation of all relational database management systems such as MySQL, Oracle, PostgreSQL and then SQL Server. See, relational model is a database model that represents data in the form of tables like rows and columns. In that, rows has been considered as tuple, column has been considered as attribute. And then moving on to basic terminology like relations as table, tuple as row, attribute as column, domain as set of allowed values for an attribute. And then we have primary key and then foreign key. Primary key uniquely identify each row. Foreign key link one table to another. See, we have been given some examples of relation, tuple, attribute. Student, in that we are providing student ID, name, age and then course ID. Tuple as rows. Same for the student ID, we are giving 101 as ID, name as Rahul, age as 20, course ID will be C1. In that attributes are student ID, name and then age. Because attribute represent the property of the entity, so it has been defined to the student ID, name and then age. Keys in relation model will be given as primary key, candidate key, composite key and foreign key. These are the 4 keys has been used as keys in relational model. Primary key uniquely identifies each tuple. Candidate key, possible choices for the primary key. Composite key, made of multiple attributes. Foreign key, links two relation together. In foreign key, we need to use 2 tables, table 1 and then table 2, with the common rows which has been in the both the tables that can be linked together to form a single table. For that we are using foreign key. And then relational algebra. See, relational algebra contains set operational, relational database specific operation and then set function. Here in set operation we are going to use set union, intersection, set difference and then Cartesian product. Relational database specific operation, we are going to use selection, projection, join and set division. Set function, sum, average, count, any, maximum and minimum. These are the functions we are going to use in the queries. We can find sum in the sense addition, like we can add and then average. With the few attributes we can find what is the average for the given para. And then count, we can count how many is there. Any in the sense it's like one of the operator. If any one is true, the output will be true for any, as well as and is also there, any and then none. It gives both are true, it gives true. Maximum we can find the maximum value, minimum we can also find the minimum value in the group. Thank you.